Hello guys, I hope you all are doing well. So we have started with a new topic that is polymer chemistry. Already two videos have been uploaded. So if you haven't seen with the video, please go with that. Link will be provided in the description. Okay. Yes. So what we had discussed in previous class, guys, just let's go with a quick recap. Okay. Yeah. So we had seen polydispersity index, right? So polydispersity index, we simply write it as PDI, which can be written as D stroke, which will be equal to weight average molecular mass divided by number average molecular mass. है ना? So the other method to represent it is weight average molecular mass. How we will represent, like, yeah, old m square, right? So old like this. Whole divided by number average molecular mass like this. So we can write it. Yes. So this is what PDI, that is polydispersity index. For a monodispersity index, for a monodispersive system, we will simply call it D stroke, which will be equal to 1. At that time, MW, that is weight average molecular mass, will be equal to number average molecular mass. This is for a monodispersive system. Okay, perfectly monodispersive system, right? Non-dispersive system. Okay, monodispersive system. And for bidispersive system, polydispersity index will be equal to 2. At that time, we will write this 2 is equals to weight average molecular mass divided by number average molecular mass. So it will be weight average molecular mass will be equal to 2 times of number average molecular mass, right? And so on, like D is equals to 3, D is equals to 4, and so on. Okay, for tridispersive system, tetradispersive system, it goes on continuous. Okay, so this much we have studied in previous class. So let's go on with the next topic, that is today's topic, that is chain dimensions. Okay, yeah. So let me erase this, guys. We have already seen this in Kalka class, right? Acha. So let me erase this. Okay. So guys, yeah, before going with the today's topic, let me introduce you one graph. Okay, on that graph also I have seen around two questions. Okay, so the graph is like fractional distillation against molecular weight. So no need to go in detail, again I am telling you. Okay, just try to note down the things whatever I am writing here. Okay, so this is a graph, it is against molecular weight. Okay, so here like this it will be, this is for number average. Okay, so this is weight average. This one it is, sorry, this one it is viscosity average. Okay, MV. And this is weight average. This one it is Z average molecular mass. The question will be like, which weight, like which will be greater? Okay, so by seeing this, I can tell Z average molecular weight will be greater than weight average molecular weight will be greater than viscosity average molecular weight will be greater than number average molecular weight. Okay, so this, the thing you need to remember here is this one. Okay, this one you need to remember. Okay, and easy trick is like, you can, if you know how to draw this graph, then you can remember this. Okay, so let me tell you the trick. Like, just go with the alphabets, guys. Okay, like first comes is N, next V, W, Z. Okay. So Z will be greater, next W, V, and N. Very easy trick, right? Okay. So if you remember this much, then you can easily trace out this. Okay. Yeah. Yeah. As I told, let us go with the today's topic now. There is length of the polymer chain. मान लो, like I have given you one polymer. Okay. ये तो एक पॉलीमर है. We know now the polymer, like it will be placed in a solution, so it will be randomly arranged. Okay, I'm considering it is arranged like this. Okay, so let me call it simply like randomly arranged polymer. Okay, randomly coiled polymer, I can tell. Okay, randomly coiled polymer. Okay, so here these are the monomer units, guys. Okay, this is one monomer unit. Yeah, sorry, completely gone. अच्छा, फिर से करेंगे. Yeah, let me draw. Okay, so this is a polymer unit. Uh, okay, this is a polymer unit. So these are monomer units. Okay, so one, this whole. Okay, what I'm telling is this whole, it is one monomer unit. Okay, yeah, this is one monomer unit. This is another monomer unit. This is another monomer unit. You are getting right like this. Okay, so totally 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, there are 9 monomer units, and length of one monomer unit, let me tell, consider it is 5 angstrom. Okay, and the other lengths will also be same. Okay, so this one, it will also be like 5 angstrom. This one, it will also be like 5 angstrom, and so on. Okay, length of each monomer unit, it is 5 angstrom. Okay, what if they ask to calculate the total length of the polymer, like end to end distance? Okay, end to end distance or total length of the polymer. So how you will calculate? How many monomer units are there in this, guys? There are totally 9 monomer units, right? Into length of one monomer unit, that is 5 angstrom. Okay, so total length of the whole polymer or a end to end distance will be 45 angstrom. Okay, so this is the thing. We can calculate in total length of the polymer. So I can call it as a one chain dimension. Okay. So in today's class, we are going to study with the chain dimensions. There are around 4 to 5 chain dimensions, guys. Okay. Like formula will be given for you. Just you need to remember the formula, that which is enough for the examination. Okay, so first chain dimension, it is counter length or maximum possible end to end distance. Counter length, or I can simply tell it as a total length, what we have calculated here. Okay, that is the first chain dimension. So on, there are other three, like root mean square distance, radius of gyration, next average radius, most probable radius. Okay, there are various chain dimensions. Simply the formula is given. If you remember the formula, the same will be applied in a questions. Okay, yes, first it is counter length, or I can tell it as total length. Okay, so the formula for this, I can tell it as n into l. Okay, so n, it is nothing but number of monomer unit. Okay, number of monomer unit, and L, it is a length of one monomer unit. Okay, length of one monomer unit. Getting? So this is what the counter length. Okay, next let us go on quickly with the second chain dimension, that is root mean square end to end distance. Okay, so let me represent this simply as RMS. Okay, root mean square radius, or we can call it as a distance, and the formula for this is root n into l. Okay, just you need to remember the formula for counter length, that is n into l, and root mean square will be root n into l. Getting? Same thing here. N is again the number of monomer unit, and l is again a length of one monomer unit. Getting? Fine. One more thing actually here, the actual, okay, just write down guys, just a second. Actually, the actual root mean square distance, okay, actual root mean square value will be greater than the theoretical one. Okay, actual root mean square value will be greater than this, than theoretical value I can tell. Theoretical value. Theoretical value. Okay. It is nothing but actual root mean square distance means which is found by a experiment, practically determined value of root mean square distance. It will be actually greater than the theoretical value, means calculated through the formula. Okay, so this is theoretically. Okay, yes. So now what might be the reason for this? Yes, just note down 2 points. Let me tell you. Just write this one. Actual root mean square value will be greater than the theoretical value. This is due to, okay, this is due to, first point, there is a fixed bond angle theta between the bonds. Okay, there is a fixed, just note down, there is a fixed bond angle theta between the bonds. Okay, there is a fixed bond angle theta between the bonds. Second one, there is a restriction in free rotation of the bond. Okay, there is a restriction in free rotation of the bond. I think you noted down. Let me explain you guys. Okay, the reason for the greater value of the actual R, that is root mean square distance, is there is a angle between the two bonds. Okay, let me call it as a arbitrary angle. Arbitrary angle. Okay, and this angle is fixed. This angle is fixed between the two bonds, and that is one point. Okay, second one is it is impossible to rotate the two bonds freely. Okay, there is a restriction in the rotation of the bonds. These are the 2 points which makes the value greater. The actual value will be greater. Okay, just remember these 2 points. If they ask in exam, then you should be clear with that much. Okay, so let's go on to the third chain dimension, that is radius of gyration. Simply remember the formula, guys. No need to go in deep. Again, I am telling you. Okay, on the basis of formula only, the questions will be asked. Clear? So radius of gyration is represented by like this. Okay. So the formula for this is root mean square distance divided by root 6. Getting? So this is a formula. So next it is average distance or the radius. Okay. So average distance, it is represented by like this, which is equal to root n into L root of 8 upon 3 pi. Okay, so this is the formula you need to remember. What is this root n into L then? ये तो रेडियस, ये तो रूट मीन स्क्वायर डिस्टेंस है ना, root n into L. So just multiply it by whole root of 8 upon 3 pi. Okay, so this is average distance, or we can also call it as a average radius. Okay, so next and the last formula is most probable distance or a radius. Listen guys, no need to go in deep. I am telling you कितना कितना चाहिए एग्जाम के लिए उतना ही पढ़ो एंड बार बार रिवीजन करते रहो. ठीक है, so the last one, it is most probable distance or a radius. It is represented by RMP, which is equal to, again, root n into L. It is common whole, like root of 2 by 3. Okay, so this is a formula. After this class, let's start solving PYQs based on this formulas and the PYQs which we need to solve on previous two classes also. Okay. So इतना काफी है. अच्छा, और एक कॉन्सेप्ट है. लेट्स गो विद दैट. Yes, degree of polymerization. You can ask me, ma'am, we have already studied degree of polymerization, which is denoted by P. And even you had given us a formula for that, that is capital M divided by small m, where capital M represents the number of, sorry, mass of polymer, molar mass of polymer, small m represents, yes, small m represents molar mass of monomer. है ना? Yes, we have studied this all the things, but the thing is, what if they won't give? Like examiner won't give you molar mass of polymer and molar mass of monomer. Then at that time, how to calculate the degree of polymerization? Okay. Yes. So let's begin. There is a small derivation based on this degree of polymerization, guys. Let's start deriving the derivation and a formula arises. So on that formula, we can calculate easily. Getting? Okay. So can you tell me in simple way what is this degree of polymerization? What I have told you? Acha, the number of monomer units. है ना? ठीक है. So I think you are revising. That's good. If you are revising, if you are not revising, please start revising, guys. Okay. So here, degree of polymerization, guys, it can also be represented as like this statement. Okay. Not only P, it can also be represented as like this. Okay. So I think you people have studied chemical kinetics. So this derivation and the formula is quite based on the chemical kinetics ka basic concept. Okay. So let me write degree of polymerization as this. Okay. So this one A naught, it is initial concentration, and AT it is final concentration. And initial concentration of a monomer. इधर मोनोमर का बात हो रहा है, ठीक है. इनिशियल कॉन्सेंट्रेशन ऑफ अ मोनोमर, ये तो final concentration means concentration of the monomer. AT is the thing with concentration of the monomer at time t. Okay. So let me simply tell you, like A, it is nothing but a monomer ka concentration. This one, it is initial concentration of a monomer, and this one AT, it is the concentration of the monomer at time t. Okay. So let me take A, okay, reacting with B, giving rise to product B. Here A and B are monomer, guys. A and B are monomer, which are reacting themselves, giving rise to the polymer B. Okay. So let me consider at time T is equals to 0. मान लो भी reaction start नहीं हुआ है. Okay. So at that time, तो A का concentration will be A naught, guys. Okay. A का concentration is A naught, and B का concentration, let me consider it as also A naught. Reaction तो start नहीं हुए है, इसलिए polymer का concentration will be 0. Getting? Now, अच्छा, और एक बात, let me explain you, like, okay, let me take it first. At time T is equals to T, okay. So what happens? Let me explain in a simple way, like A, that is one monomer, A monomer reacting with a B monomer, giving rise to the polymer P. मान लो at T is equals to 0, A का concentration तो 10 है, 10 मोल पर लीटर, ठीक है. एंड B का concentration भी 10 है, पॉलीमर का concentration 0. ओके. आफ्टर 5 मिनट्स, लेट मी कंसिडर आफ्टर 5 मिनट्स के बाद क्या होता है, पॉलीमर का concentration means some reaction has happened. So polymer ka concentration, let me consider it as 4. Okay, 4 mole per liter. So if 4 mole per liter the polymer has been formed, then definitely it will be 10 minus 4 and it will be 10 minus 4. Means from 10, 4 mole per liter has been converted to the product. Getting right? From 10, from 10, 10 is the concentration of A. From 10, 4 mole per liter of A is converted to polymer. That is, okay. So here what happens actually at time t, like at time at 5 seconds, what happens? The concentration of A will be 6 and concentration of B will be 6 and concentration of the polymer P will be 4. This is at time t, that is at 5 seconds or 5 minutes I can tell. Okay. So similarly, I can tell here that at time t, polymer का concentration will be 80. Okay. So, sorry. Polymer का concentration will be X. Let me consider. Then definitely at time t, A का concentration was initially it was A naught. From A naught X, that is it that much it is converted to the polymer. Again here also I can write it as like this. Okay. So at time t, let me represent this as A naught, that is concentration of A at time t. Okay. Like here 6 how we had taken. This is also 80 and this will be X. Getting right? Okay. So if you got this, let me erase. Just write 80 is equals to A naught minus X. Okay. 80. Now 80 will be definitely equal to A naught minus X. Getting? So X will be equal to A naught minus 80. Okay. So now let me calculate fraction of monomer reacted. Fraction of monomer reacted. Fraction of monomer reacted represented by P. Okay. So it will be equal to X divided by A naught. How much monomer is converted to product? Okay. How much monomer is converted to product? X. Okay. X, that much concentration is converted to product. Right. मान लो, like, let me give you a simple example. You have attended one exam and the exam, like, it was a test where it has 600 marks. Okay. It has 600 marks and you are getting 500 marks out of 600 marks. Okay. So total marks it was 600. Obtained marks it was 500. So can you tell me fraction of marks obtained? Fraction of marks obtained. Yes, fraction of marks are obtained will be how much marks you have obtained divided by total marks, है ना? So same way fraction of monomer reacted will also be like how much it is converted divided by total concentration of the monomer. Concentration of the monomer which is converted to the product means which is decomposed monomer reacted divided by total concentration of the monomer. Getting? Okay. So P will be equal to X upon A naught. Therefore, X will be equal to P into A naught. Right. So we know that. Let me consider this as equation 1 and this as equation 2. Putting equation 1 into X का value तो A naught minus AT will be equal to P into A naught. Right. Okay. Just do one thing. Take this A naught this side. Okay. On the left hand side. So it will be A naught divided by A naught minus AT divided by A naught, which is equals to P. Okay, A naught get cancelled, so it will be 1 minus AT by A naught, okay, will be equal to P, right? So let me simply write here. Okay, so AT by A naught will be equal to 1 minus P, right? Yes or no? 1 minus P. So what is degree of polymerization according, here I have written that is A naught by AT. So let me do reverse, that is A naught by AT will be equal to 1 upon 1 minus P, right? So this is the final equation to calculate the degree of polymerization if molecular weight is not given. Okay. So at the time they will provide you the is P here, fraction of monomer reacted. Okay. So P is a fraction of monomer reacted. They will provide the fraction of monomer reacted. So simply just do 1 upon 1 minus P. We will get degree of polymerization, that is A naught by AT. Clear? Yeah. Now again, here we had considered one equation, right? The A plus B giving rise to P. Okay. So let me consider rate constant K. Like for this reaction, rate constant is T, K, and the time taken for the reaction is T. What if they provide you rate constant K and time taken for the reaction T? How to calculate degree of polymerization? Acha. So again, there is one more formula, guys. Let's see that formula. If they, in the question, if rate constant and a time taken is given, then we can calculate degree of polymerization. Okay, so this is one of the important formula. Just mark it a star mark. Getting? Okay. Let me consider reaction A plus P giving rise to P. Okay, rate constant K and T is the time taken for the reaction. Okay, so by seeing this reaction, definitely we can understand the reaction is second order. So for second order reaction, from kinetics, there is, from chemical kinetics, there is one formula. Okay, for second order reaction, KT will be equal to 1 upon AT minus A naught. Okay, so this is a formula which is taken from the chemical kinetics. If the reaction is second order, then we can simply write it like this. Okay, so just do one thing, like multiply A naught on both sides. Okay, multiply A naught on both sides. So it will be A naught KT will be equal to A naught by AT, right, minus A naught by A naught. Okay, so cancel A naught, it will be A naught KT will be equal to A naught by AT minus 1. Okay, so A naught by AT will be equal to 1 plus A naught KT. So this is the equation we can use when initial concentration rate constant. Okay, so initial concentration rate constant and the time taken is given. Getting? We know, right? This is nothing but degree of polymerization only. So you can also write it as like this. Getting? Yeah. So So itna kafi hai, guys. In the next class, let's solve with the problems which are asked in PYQs. Okay. So if you do that much from polymer chemistry, that is well and enough for the purpose of examination. Okay. So guys, let me tell you one more thing, how we got this formula, okay, from chemical kinetics, okay. If you have studied chemical kinetics, then you will be easily understand this, how this formula I have taken. But if not, then guys, there is one general formula, like general formula, let me consider. There is a general formula, okay. It is K and T is equals to 1 upon n minus 1 whole bracket AT raised to n minus 1 minus A naught raised to n minus 1. Okay. So this is the formula which we use to get this actual formula. Okay. So manlo, like for second order reaction itself. Okay. For second order reaction, what happens? Where n is a order of the reaction. Okay. So for second order reaction, it will be K2T, right? K2T. What is K2? It is rate of second order reaction. Okay. So K2T is equals to 1 upon where n is 2. So it is 2 minus 1, 1. Okay. Into bracket 1 upon AT. Okay. AT raised to 2 minus 1. It is 1 minus 1 upon A naught raised to 1. Right. So I can simply write it as KT is equals to 1 upon AT minus A naught. Right. So this is what the equation is. Getting? So what if for third order reaction? Like for third order reaction, how we will write is K3T. What is K3? Rate of third order reaction. Okay. Rate constant of third order reaction. K3T will be equal to 1 upon here. This is a general formula you need to consider. Okay. So it is 3 minus 1, 2 to bracket is to 2 minus is to 2. Okay. So like this, we use this general formula, and again, a very important formula in the chemical kinetics. Okay. From that, we got this equation. Clear, everyone? So if you are having any doubt, please do comment, guys. And so this much is enough. Let's go in the next class. Let's solve with the PYQs. Clear? Okay, bye. See you. Take care.